Hello everyone, welcome to askIITians. I'm your mathematics mentor Manish Nehalani, and today this is lecture number 2 of understanding quadrilaterals from class 8 chapter, right? So we would be discussing today, as I said, that this chapter is very much important from your final examination point of view, and this is just the basics of polygons and quadrilaterals. Many more interesting concepts are being continued of this chapter in your higher classes, that is grade 9 and grade 10. So if you understand this chapter very well and if you're good at dealing with this chapter is going to help you in your higher classes as well, right? So these are the topics which we are going to cover today, that is types of quadrilaterals, trapezium and its properties, kite and its properties, parallelogram and its properties. So first, let's try to understand what are the different types of quadrilaterals we have. In the last class, I think we had discussed that what is a quadrilateral, what is a polygon, how is a what a closed polygon, open polygon, regular polygon, irregular. Then we also saw a glimpse of convex and concave polygon, right? So these things we had discussed already. Today we would be talking about types of quadrilaterals, right? So now we can say that there are six basic types of quadrilaterals which are there in your curriculum for now. There are a couple of more as well, but these are the main categories which you can consider for now, right? So there are, this is trapezium, parallelogram, then we have rectangle, rhombus, square and kite. So we will analyze one by one to each quadrilateral and we will study their properties, right? So if you just look at this figure, that is look at this chart, it says that a square, in a square is again a quadrilateral. It has four right angles and all sides of a square are equal, which means all the sides are equal and all angles are 90 degrees, right? Opposite sides are parallel and all sides are of same length. As this is a square, so we already know what a square is like. Maybe a ice cube looks like a square, or if the face of ice cube is a square, then if you just look at a book which is a square book or equal length and equal width book, from top you will come to know that it is a square. A chessboard is a square, right? And basically there are many examples of square which you can relate. Then we are talking about rhombus. So we know that if you just push the side of a square from top, you would be getting a rhombus, because in the difference between a rhombus and a square is like the rhombus does not have right angles, right? And also there is a diagonal difference in a rhombus, that is diagonals of a rhombus are not equal whereas diagonals of a square are equal. Then all sides are equal in a rhombus as well, that is all sides are equal in a rhombus. Opposite sides are parallel, four equal sides are there, yes. Then we will talk about kite. Kite is again a quadrilateral, right? Because it has four sides. So it has two sets of equal sides. That is, when you talk about a kite, this side is equal to this side, and these two longer sides are equal to themselves, right? Now, in a kite, no two sides are parallel, right? This is what you have to understand, because kite is like a kaju katli, right? We know kaju katli is kite shaped. So इसमें कोई sides parallel नहीं है as such. And kite matlab patang, right? We have been celebrating in India during Makar Sankranti, and there is a kite festival in the month of January, right? So along with it comes with Lori and other festivals. So this is what kite is. These are the properties, that two pairs of equal sides are same length. Then rectangle. So in a rectangle, the difference between square and a rectangle is that opposite sides are equal in a rectangle. Although all angles are right angles, but in a square, all four sides are equal. But in a rectangle, just the opposite sides are equal. Right? Just the opposite sides are equal. Not all sides are equal in a rectangle. Okay. Again, when you push a rectangle, you get parallelogram. When you push a rectangle from top, you get a parallelogram, right? That is, as we pushed a square, we got a rhombus. When you push a rectangle, you get a parallelogram. That is, parallelogram will not have any right angles, but its opposite sides would be equal. Opposite sides would be equal and parallel, right? That is why the name is parallelogram. These two sides are equal, opposite sides, and they are parallel as well. Again, parallelogram is a quadrilateral because it is a four-sided figure, closed polygon. Then we have trapezium. Trapezium is a very interesting, you can say, quadrilateral because only one pair of opposite sides is parallel. So there are lots of trapezium because you can say it's only one pair of opposite sides which is parallel. You can connect the rest to anyhow, right? So you would say here two sets of parallel sides, right? Now you can also say that if these two sets are equal, then in that case we would be saying that yeah, this is isosceles trapezium. But every trapezium need not be isosceles, right? So one set of sides are parallel, sides can be of any length, right? Sides can be of any length. So two sets of sides are equal, but these two sides, that is, if you name this trapezium as ABCD, AB is parallel to CD. This is what is the property of trapezium. One pair of opposite sides is parallel, right? So these are the different types of quadrilaterals, and let's try to solve a couple of questions based on this. So it says a quadrilateral has dash sides. So this we had discussed in the last class also, that a quadrilateral means it has four sides, right? And also if it has four sides, a quadrilateral has four angles as well, right? And a quadrilateral has four vertices, no three of which are collinear, right? We will say that no three of which are on the same line. If the vertices will be on the same line, it will not be a quadrilateral, it will become a triangle. What do you mean by collinear? Collinear means they are on the same line. So if three vertices of a quadrilateral are on one line and one vertex is on some other line, then this is no more a quadrilateral. You can at most form a triangle using these three vertices, right? So you would say that this is a quadrilateral in which four vertices has four vertices, and no three should be collinear, because at most two can be collinear in the same line, right? So even if two are in the same line but remaining two are not, when you join those four, you get a quadrilateral, right? So then it says a quadrilateral has dash diagonals, right? So at most a quadrilateral can have two diagonals, right? A quadrilateral can have two diagonals, because even if you consider rectangle, square, trapezium, or any other uh, quadrilateral, you would get only at max two diagonals. So it says a diagonal of a quadrilateral is a line segment that joins two opposite vertices of a quadrilateral, right? That joins two opposite vertices of a quadrilateral, because adjacent vertices तो sides हो गया ना, adjacent vertices are just side, right? So that is why diagonal means or connects the opposite vertice of the quadrilateral. Then we had discussed this in the last class as well, angle sum property of a quadrilateral, right? So when you like add up all the angles, how many angles are there? We discussed, we said there are four angles. So when you add those four angles in a quadrilateral, you would get the sum as 360 degrees, because a quadrilateral can be divided into two triangles. Sum of angles of a triangle is 180, so therefore sum of angles of a quadrilateral is 360 degrees, right? So these are the basically solutions of these as we discussed. Let's now understand each and every quadrilateral separately. So it says trapezium first. Trapezium is a quadrilateral which is defined as a shape with four sides and one set of parallel sides. So there is a trapezium. Now you all can see these arrows. These arrows represents the sides which are parallel. The sides are parallel, right? Arrows represents the sides which are parallel. So a trapezium, all of these yellow, blue and green, they represent a trapezium. So one pair of sides is parallel, the other can be non-parallel and need not be equal also. Now this specific trapezium in which the non-parallel sides are equal, the non-parallel sides are equal, this trapezium is called as isosceles trapezium. This trapezium is called as isosceles trapezium, right? Correct. So then what are the properties of trapezium? So you would say a trapezium has four unequal sides, right? Because we will not be we are not talking about just isosceles trapezium, we are talking about a random trapezium, any trapezium. It has two parallel and two non-parallel sides. Again, since it's a quadrilateral, sum of all interior angles will be 360 degrees, because it is always equal to 2n minus 4 into 90 degree. Here n is equal to 4, right? Diagonals bisect each other, which means when you try to draw, how many diagonals will it have? Since it's a quadrilateral, it will have two diagonals, right? It will have two diagonals, and these diagonals bisect each other. That is AO equal to CO and BO equal to DO. This is the property of trapezium, right? So now let's move forward with another quadrilateral, that is kite. Kite is a quadrilateral that has two pairs of equal length sides. These are adjacent to each other. As you all can see in the diagram ABCD, this is a kite. ABCD is a kite in which AD equal to CD, right? AD equal to CD and AB equal to BC, right? Now, this is one important definition of kite. It's a quadrilateral. Then the other properties are like two distinct pairs of adjacent sides are congruent, right? As we discussed already. Then diagonals of a kite intersect each other at right angles. That is, AC is perpendicular to BD. AC and BC are perpendicular. They intersect each other at right angles, as you all can see in the diagrams as well, right? This diagram. This is 90 degree. One of the diagonals is the perpendicular bisector of the other, which means this just one diagonal is the bisector, the other one doesn't bisect, right? Which means just AO is equal to CO, and you also have to understand that BO is not equal to DO, right? Only one diagonal bisects the other. That is how it is. One diagonal bisects the other. One of the diagonals bisects the other. That's how it is. So then the next important is angles between unequal sides are equal. Basically, angles between unequal sides. Now, what are the unequal sides? Unequal sides means angle BAD, because BA and AD are unequal sides. So angle between these are equal, which means angle BAC is equal to angle BCD, or rather BAD is equal to BCD, right? These two angles are equal in a kite. Okay, so this is how we understand the properties of kite, and it's very important to understand that only one diagonal bisects adjacent sides are equal, right? Also, they need not be parallel. You all can see that it is a kite. None of the AB is not parallel to CD or anything like that. It is a quadrilateral because it has four sides, right? Then we have parallelogram, right? Parallelogram, as we said, if you just push the rectangle from top, you get a parallelogram. So if a quadrilateral has a pair of parallel opposite sides, then it's a special polygon called parallelogram, right? That is, AB is parallel to DC and AD is parallel to BC, like that, as you all can see in the arrows. Now this is a very important quadrilateral because this is a general parallelogram, whereas when you talk about rectangles, squares, these all are also parallelograms itself with additional properties of parallelograms. So it's not necessary that when we are discussing properties of rectangle, we might also discuss properties of parallelogram, because when you are talking about a rectangle, it is already a parallelogram. Right, because when you are saying opposite sides are equal, they have to be parallel, right? And all angles are 90 degree, which means it is a specific case of a parallelogram. It will definitely follow all properties of parallelogram, but in addition to that, what are the properties of a rectangle, we will discuss that. right? So that is why a parallelogram is a very important quadrilateral, because many other quadrilaterals which are more specific to which have more specific properties are also parallelograms, right? So for a parallelogram, the opposite sides are parallel and equal. The opposite sides are parallel and equal as well, which means AB is equal to CD and AD is equal to BC. Opposite angles are equal as also in measure angle A is equal to angle C and angle B is equal to angle D, right? Consecutive angles are supplementary, which means when you talk about adjacent angles, so here consecutive means adjacent, right? So adjacent angles are supplementary, means they add up to 180 degrees, right? So therefore you'd say angle A plus angle D is equal to 180 degrees, and angle B plus angle C is also equal to 180 degrees, right? Also there is this important property that diagonals of a parallelogram bisect each other. Diagonals of a parallelogram, this is a shortcut way to write parallelogram: double parallel lines and M at the top. Parallelogram bisect each other, right? Therefore A equal to VC and BE equal to DE, right? So I hope you all have understood the things. What is a trapezium, what is a kite, what is a parallelogram, and what are their properties, as we were saying, right? So if you again look at it, if one of the angles is a right angle, then all others have to be a right angle. This is also, then two diagonals bisect each other, as we said. Each diagonal bisects the parallelogram into two congruent triangles, right? So when you see about a diagonal BD will divide the parallelogram into two congruent triangles, which means uh, all four all four triangles in a parallelogram are congruent, right? So in this case, you can say that if the adjacent sides are also equal, right? So this is about parallelogram. Now there are some specific properties of parallelogram which you need to discuss in case of special parallelograms, that is a square and a rectangle. So it says sum of square of all sides of a parallelogram is equal to sum of square of its diagonal. It is called as parallelogram law, which means sum of squares of all the sides. So if you are considering a parallelogram ABCD, okay, let's say this is parallelogram ABCD. So sum of square of all the sides, that is AB square plus BC square plus CD square plus AD square. This is equal to sum of squares of its diagonals, that is AC square plus BD square. AC square plus BD square. This is known as parallelogram law. Okay. Now, a rectangle is also a parallelogram if and only if its diagonals are of same length. A rectangle is a parallelogram if its diagonals are of same length, right? So we would say yes, rectangle is a parallelogram because all angles are 90 degrees and opposite sides of a rectangle are equal, right? Then a quadrilateral is a rhombus if and only if its the diagonals are perpendicular bisectors of each other or bisect all the vertex angles. So a rhombus also has, as we had discussed, when you push a square you get a rhombus. So if we say that it is PQRS, this is a rhombus. So this will have, if the diagonals are perpendicular bisectors of each other, that is PR is bisecting QS, right? Then these are perpendicular bisector and they bisect at vertex angles. So P is the bisector, or rather PM is the bisector of angle P, QM is the bisector of angle Q, and SM is the bisector of angle S, and RM is the bisector of angle R. So if this is the case, we would say this is a rhombus. Okay. So these are the additional properties of parallelogram and rhombus, and also condition for a parallelogram to be a rectangle. Okay. So these are the things which we have discussed. So if you all can see that the logo of various companies like NASA and Mitsubishi's, so these logos are made up from quadrilaterals. Like this is, if you consider, this is a rhombus, this is a parallelogram, and this is also a parallelogram. So these are various things which we need to know. So now let's try to solve this question. It says in a given parallelogram ABCD, so if it's a parallelogram, it will follow all the properties of parallelogram. So it says that if a given parallelogram angle A is 90 degree, you have to show that all other angles are 90. So we can clearly say that opposite angles of a parallelogram are equal, right? As we discussed in the property. So you would say therefore angle A equal to angle C, since opposite angles of a parallelogram are equal. तो ये हो गया, therefore angle C भी 90 हो गया, right? 90 degree. Similarly, we also know that adjacent angles of a parallelogram are supplementary, as discussed just now, right? Supplementary. So therefore angle A plus angle B is equal to 180, but angle A to 90 hai, therefore angle B will be equal to 180 minus 90, which is just 90, right? Now again, if you use the opposite angles are equal wali property, you will get therefore angle D is also equal to 90. So if one angle in a parallelogram is 90, all other angles are also 90. This is how we use opposite angles are equal, adjacent angles are supplementary, right? I hope like in a classroom you all must be raising your hands that okay, I have like I wanted to answer sir before you. Great. So let's now solve next question. It says if in a parallelogram ABCD, AC bisects angle A, right? So we can see that, and also angle C is also the bisected. So angle 3 is equal to angle 4, angle 1 is equal to angle 2. This is given. Okay, you have to show that AC is perpendicular to BD, right? Which means you have to basically show that the angle E pe you are getting a right angle, right? So how do we show this? We would say consider triangle ABC and ADC. So considering triangle ABC, right, and triangle ADC. By the ASA criteria, the two triangles are congruent. This means AB equal to AD, right? Why are they congruent? Because these two angles are equal, and this is given to us, right? This is given angle 1 equal to angle 2 and angle 3 equal to angle 4. This is given to us, and we are also saying that AC is a common side. So angle side they are equal. Therefore, AB will be equal to AD, right? Similarly, we will also say that triangle AEB and triangle AED, the larger triangles AEB and AED, they are also equal because now they have one common side, they have the other side, and it is also given that it is a bisector. AB equal to AD as proved above, right? And we know angle 2 equal to angle 1. So by SAS, these triangles are also congruent. Therefore, AEB plus AED, they all add up to 180, we know, right? angle AEB. So you'll say measure angle AEB plus measure angle AED. This is equal to 180 because angle formed by a straight line, right? And we just now said that since measure angle AEB is equal to measure angle AED using CPCT, right? So now if these two angles are equal, therefore each one of them has to be 90 degrees. And if they are 90 degrees, we can conclude that AC is perpendicular to BD, right? AC is perpendicular to BD. Correct. So we would be able to now solve these questions. So you can try these questions as a part of your homework. That is, prove that when a parallelogram diagonals bisect each other, they bisect at 90 degree, and it is a rhombus in that case. Then if a diagonals in a quadrilateral bisect each other, you have to prove that it is a parallelogram, right? So these are some practice questions which you can try, and we'll see them in the next class. Till then, please take care of yourself, because during this pandemic it's like getting difficult, for many things. But I want you all to remain safe so that we can keep learning and take care of yourself, take the necessary precautions which are required. And till then, stay safe and keep learning from us Skytians. Okay, see you all in next class. Thank you.